Section 3.9 today. Two topics. Topic 1, examples about the derivative formulas for exponential functions and logarithmic functions. Second topic, logarithmic differentiation. Now, before I present these two topics, let me show you a complete list of the derivative formulas that we need to remember. There are 11 formulas that we need to remember. 10 are from section 3.3, 3.4, and 3.5. One is from section 3.7. The one from section 3.7 is the chain rule. Now today, in topic 1, I want to show you examples about these two formulas for exponential functions and these 4 formulas for logarithmic functions. Now, topic 1. Example 1. Differentiate this function. This function is log of absolute value of 2 plus psi of x. The base of the log is 10. To compute the derivative of this function, I want to use this formula. So I need to simplify the function. I let u below 2 plus psi of x. Then the function becomes log of absolute value of u. Because x and u are different, I need the chain rule. I write this derivative as the product of these two derivatives. Now, for this derivative, I can apply the formula here. This derivative by formula is 1 over u times natural log of 10. Now, remove the intermediate variable u. Plug in 2 plus psi of x in the u here, then I have this equation. Now, compute this derivative. The function is 2 plus psi of x. By summation formula, derivative of 2 is 0. Derivative of psi of x with respect to x is cosine of x. Simplify this expression a little bit, then this is the answer to this example. Example 2. Find an equation of the tangent line to the curve at the given point. The given point is 1, 0. The curve is the graph of this function. Suppose this blue curve is the graph of the function. The point 1, 0 is here. At this point, there is a tangent line, and we need to write down the equation of the tangent line. About this tangent line, now we know one point on it. We need to determine the slope of the tangent line. Then, by the point slope formula, we can write down the equation of the tangent line. To find the slope of the tangent line, we compute the derivative. Take derivative on the function. The function is a product, x squared times natural log of x. So we apply the product rule to compute this derivative. By the product rule, this derivative is equal to derivative of the first function times the second function plus first function times the derivative of the second function. Derivative of x squared by the formula for power function is 2x. Derivative of natural log of x by this formula is 1 over x. Now, cancel 1x here, then this is the derivative of the function. And also, this is the slope of the tangent line at a general point x. After we get the derivative, then we can tell the slope of this tangent line. Plug in 1, the x coordinate of this point, in the x here. Then the slope of the tangent line at the point 1, 0 is 1. Now we have the slope of the tangent line and we have 1 point on the tangent line. By the point slope formula, the equation of the tangent line is this. Simplify this equation, then this is the answer to this example. Example 3. Differentiate these functions. Part A. The function in part A is a product. E to x times x to e, where e is a constant, an irrational number. The value of e is 2.71 something. Just like pi. Pi is also an irrational number. Pi, the value is 3.14 something. Because the function is a product, I apply the product formula to compute the derivative. By the product formula, the derivative is equal to derivative of the first function. First function is e to x times the second function. Second function is x to e plus first function times derivative of the second function. E to x derivative by formula is ex. X to e by the formula for power functions is e times x, e minus 1. Now simplify this expression a little bit. I move this e in the front. Then this is the result to part A. Part B. Take derivative on this function. This function is a constant function. By calculator, 2 times e to square root of 2 is 8.22 something, a constant. So derivative on this function is 0. Part C. The function in part C is 2 times a power function. The power is square root of 2. Now, take derivative on this function. I first move the constant to outside the derivative to get this equation. Now, derivative on x to square root of 2 by the formula for power function is the power square root of 2 times x to the power minus 1. This is the result to part C. Part D. The function in part D is an exponential function. The base of the function is 4 and the power is negative 2x. To compute the derivative of this function, I want to apply the formula for exponential functions. Now, take derivative on the function. In order to use this formula, I need to simplify the function. I let u below negative 2x. Then the function becomes 4 to u. About this derivative, because u and x are different, I cannot directly apply this formula to compute this derivative. Before I can compute this derivative, I need the chain rule. I insert du to the bottom and a du to the top. Then this derivative is equal to this derivative times this derivative. This derivative, I can apply the formula here. It is by formula 4 to u times natural log of 4. Now remove u. By u, I mean negative 2x. Plug in negative 2x in the u here, then I have this equation. Now, for this derivative on negative 2x with respect to x, it is negative 2. Then this is the result to part D. Part E. The function in part E is a constant times a function times another function. To compute the derivative of the function, I apply the product formula. Now, take derivative on the function. I first move out the constant to get this equation. Now, the function under this derivative is a product. By product formula, this derivative is derivative of the first function times the second function plus the first function times derivative of the second function. So I have this equation. About this derivative, I have computed it in part D. I just need to plug in the result in this derivative. Derivative on natural log of x by formula is 1 over x. Therefore, this is the result to part E. Topic 2, logarithmic differentiation. Logarithmic differentiation means use log to simplify a function before computing the derivative of the function. Functions involving products, quotients, or powers can often be simplified by taking a logarithm. Here are some properties about a log function. We use these properties in logarithmic differentiation. Property number 1, log of a product is equal to the sum of the two logs. This property says that log reduces a product to a sum. Property number 2, log of a quotient is the difference of the two logs. In this property, log reduces a quotient to a difference. Property number 3, log of a power is the power times log. Log reduces a power to a product. Property number 4. Lateral log of e to m is m. E to lateral log of m is m. In these two formulas, lateral log and e cancel each other. Please note that we don't have any formula for log of a sum or log of a difference. Take a look at some examples about logarithmic differentiation. Example 1, find this derivative. About this example, we have two solutions. Solution 1 is a standard solution. In solution 2, I use logarithmic differentiation to compute the derivative. Namely, I first use the properties of log to simplify the function, then compute the derivative. Solution 1. The function is complicated and I want to simplify the function. I let u below the quotient here, then the function becomes lateral log of u. Now, I need to compute this derivative. Because x and u are different, I need the chain rule. By the chain rule, I write this derivative as the product of these two derivatives. The derivative of lateral log of u with respect to u is 1 over u. Now, plug in this quotient in the u here, then I have this equation. When I compare this derivative, I apply the quotient formula. In the quotient formula, I need to compute the derivative of the bottom, square root of x minus 2. To compute the derivative of square root of x minus 2, I need the chain rule again. This solution process is standard and is time consuming and tedious. Let me stop this solution here and turn to solution 2. In solution 2, I first simplify the function, then compute the derivative. By the properties of a log function, lateral log of a quotient is lateral log of the top minus lateral log of the bottom. The bottom is a power. Lateral log of a power is the power times lateral log. We can move down the power to the front. Now, the function here is simple enough. Take derivative on this function and on this function. Then I have this equation. To compute these two derivatives, I apply the chain rule. I let u be x plus 1, w be x minus 2. Then I have this equation. Now I apply the chain rule to this derivative and to this derivative. Then I have this equation. Lateral law of u derivative with respect to u is 1 over u. Lateral law of w derivative with respect to w is 1 over w. Then I have this equation. Plug in x plus 1 in u. Plug in x minus 2 in w. Then I have this equation. Derivative on x plus 1 with respect to x is 1 plus 0. Derivative of x minus 2 with respect to x is 1 minus 0. Simplify this expression, then this is the result of this derivative. Example 2. Differentiate this function. Solution. Simplify the function by taking a logarithm, usually taking a lateral law of both sides of the equation and using the properties of logarithms. Take lateral law on the both sides of this equation. Then I have this equation. Now I want to simplify this function. By the properties of logarithms, lateral law of a quotient is lateral law of the top minus lateral law of the bottom. The top is a product, this function times this function. Lateral law of a product is lateral law of the first function plus lateral law of the second function. Square root of x squared plus 1 is a power. It is x squared plus 1 to 1/2. Now, move down the powers. Then I have this equation. The function on the right side of this equation is simple enough. We cannot further simplify this function. Now, take derivative on the both sides. Then I have this equation. Apply the summation rule, the subtraction rule, then I have this equation. Move out the constants. Then I have this equation. Now, simplify this function and this function by introducing intermediate variables u and w. U denotes x squared plus 1. W denotes 3x plus 2. Then I have this equation. In this equation, I have 1, 2, 3, 4 derivatives to compute. For this, and these derivatives, I need the chain rule. Write this derivative as the product of these two derivatives. And write this derivative as the product of these two derivatives. Write this as the product of these two derivatives. Now, derivative of lateral log of y with respect to y is 1 over y. Derivative of lateral log of x with respect to x is 1 over x. And this is 1 over u, 1 over u. This is 1 over w, 1 over w. Now, plug in, remove u and w. U is x squared plus 1. Plug in x squared plus 1 in the u here. And plug in 3x plus 2 in the w here. Then I have this equation. Derivative on x squared plus 1 with respect to x is 2x plus 0. Derivative of 3x plus 2 with respect to x is 3 plus 0. Simplify the right-hand side of this equation. 3 over 4 times 1 over x is 3 over 4x. And 2x plus 0 is 2x. Cancel 1, 2, then the second term here is x over x squared plus 1. The third term, 3 plus 0 is 3 times 5, 15. So the third term is 15 over 3x plus 2. We are looking for dy dx. Move 1 over y to the right-hand side, then I have this equation. In this example, I know the function y. The function y is this. Now, plug in this function in y. Plug in the function in the y here, then I get the final answer. Derivative of y is equal to this function.